Good day. Welcome to Electrical Engineering 1 tutorial session online course. Today in this session, I will be solving 3 problems on sinusoidal waves and inductor. Now, let me just, this is your sheet 5, okay? So let us start with sheet 5. Now, first question is, before we see for first questions, let's see some definitions. What do you mean by sinusoid? Okay. Now, according to this, let me give you the definition. A sinusoid, you can just take down notes when I'm writing, okay? Sinusoid is a signal that has the form of the sine or cosine wave, sine function, okay? Generally, a sinusoid current is usually referred to as alternating current, AC, such as current reverses at regular time interval and has alternative positive and negative values like that. AC circuits drive by sinusoidal current or voltage sources are called as AC circuits. AC is more efficient and economical to transmit over long distances and hence won the battle with DC. So that's why AC will use AC. There are a lot of applications of sinusoidal waves. Okay, sinusoid signals are easy to generate and transmit, and they are it's dominant form of signal used in communication and electrical power engineering. And for any practical, periodic signal can be represented by sum of sinusoids through Fourier analysis. Sinusoids are easy to handle mathematically because you need to do with derivation and integration. And the good point is for sine and cosine waves, their integration is again a sine. For cosine, integration is again a cosine. Okay. So any we can use any of the function to represent a sinusoidal signal. So let me there are different ways. Okay, you can represent in any way sinusoidal signal. Sinusoidal signal, you can represent them in any one of these following. Either you can represent them as v of t is equal to Vm sine omega t. This is not W, just call it as omega, okay? Or I write omega t plus pi. Okay. Or you can also write it as V of t is equal to Vm cos omega t plus phi. So the best way to write them is I'll use the pencil. This is a sine of, okay, sine of, you'll write this omega t plus phi. This is phi. Okay. Similarly, this is Vm cos omega w omega t plus phi. Okay, this is about the signals. So now we will see the first question. Before we go for the first question, we need to know some important points about sinusoidal signal, which I have just now discussed. Okay. Now, what is Vm in this? Vm is nothing but this Vm here. Let me use this red color. This Vm is nothing but maximum voltage. Vm is nothing but maximum voltage, and you can find out the average voltage with the help of Vm. How? Vm is the maximum voltage, and you can find out the average voltage by just dividing this maximum voltage Vm, okay, by, if you do pi, this is not phi, this is pi is 24 by 7, okay. When you do this, you will get average voltage. Similarly, using this Vm, you can get one more value called effective voltage or RMS value. Okay, root means square value, and the formula for Vrms is Vm by root 2. Vrms RMS is equal to Vm by, okay, root 2. This is root 2, okay. So remember, if you know the Vm, that is a maximum voltage, then you can find out average voltage using this formula Vm by pi, and you can find out effective voltage or RMS value using this formula Vrms is equal to Vm by root 2, okay. And what is this phi? This phi is called phase shift, okay. This is called phase shift. Similarly, from this equation, you see you have an omega here. What is omega? Omega is nothing but 2 pi f. Omega is nothing but 2 pi f. Okay? So generally, you will write like this: 2 pi f omega. Sorry, I don't write properly because I have to write this with mouse. 2 pi f, okay. This is the formula for omega. Omega is equal to 2 pi f. This is what is f here? F is called frequency, and omega is called angular frequency. F is called frequency. Remember, okay. F is called frequency. I just write down f as frequency, and omega. What is omega? Omega is called as angular frequency. Okay, this is called as an angular frequency. Okay, so this is an angular frequency. So remember, from this equation, you have V of t is equal to Vm sine omega t plus pi. From this, you got Vm. Vm is the maximum voltage, and from this maximum voltage, you can find out the average voltage using Vm by pi, and you can find out the Vrms or effective voltage using the formula Vrms is equal to V maximum by root 2, and you can find out the phase shift is phi, and you can find out the angular frequency, which is f, with a relation omega is equal to 2 pi f. F is the frequency and omega is angular frequency. Okay, and you know that there is one thing called periodic time. What do you mean by periodic time? Periodic time is nothing but t. T is the periodic time, is nothing but 1 by f. Okay, this is your periodic time. Okay, so all these things are very important for you to solve first problem. Okay, now let us go to the first problem in our sheet 5. So I'm just taking you through this. I hope you see my screen. 1 minute. Yeah, so okay, do all of you able to see my screen? We have sheet 5. The first question is given as for sinusoidal signal supply, V of t is equal to 700 sine 0.085 T plus 15 degrees volt. Okay. Now we have to find in the first sheet like 5 6 values just now which I have discussed, like what is maximum voltage, the average voltage, effective voltage or RMS value. Find out the phase shift, the frequency, the angular frequency, and the periodic time. So all these things you need to find out. Okay. So let us go to the next slide for the first solution. Let's see the maximum voltage. Now, how do you find out the maximum voltage? It's already given. What given? Uh, Let me use the highlighter. It's already given that V of t is equal to, from here, V of t is equal to 700 sine 1085 t plus 15. So this is given as V of t. Just I have note down this. V of t is this word. And also we have to write our, see, this is the sinusoidal wave is represented with the help of sine function. You see here it is represented with the help of sine function. So as I have told you, you can represent a sinusoidal wave either in sine or cosine. So here in the problem he has given in terms of sine. So what I have to do is I have to write a sinusoidal wave equation. V of t is equal to Vm sine omega t plus theta. Okay, means phi actually it is. Okay, theta or phi, these are called phase shift. Okay. Now see here 700. I'll use the pen. Yeah. Now you see Vm is nothing but here. Let's write. I will take an option of ink for red. Okay. So Vm is how much? 700. From this you got maximum voltage equal to 700, and omega from here you got it as 1085 T, and then you got 15 degrees. This is your phase shift. Okay. So all these values are given. Now from this, what is the value of maximum voltage? It is 700. Vm is equal to 700. Okay, we got this answer. So Vm is 700. Right? You have any questions? No. Okay. Now let's go for next problem.